Chem 107 students. Now we're going to talk about Lewis dot structures, but before we get there, I have some background information for you. So first of all, in our atom, electrons go around our nucleus, but they can't just be anywhere. They have to be in a certain energy level or orbit, if you will. So if you look at the picture here, we see we have our nucleus, then we have energy level 1, around the nucleus. An electron can be at that distance from the nucleus on that level. Then we have energy level 2, and then we have energy level 3, and it keeps going. And the electrons can be on a level, but not in between. So, and there's a lot more to this, but this is good enough for Chem 107. Level 1 can hold up to 2 electrons. Level 2 can hold 8, level 3 can hold 18, and it just keeps going. So the important thing from this slide is that electrons go around the nucleus in levels. Now, valence electrons. The outermost level of electrons are called the valence electrons. They're the most important electrons to the atom because they're the ones that can bond with other atoms and make molecules. Molecules mean you have 2 or more atoms and they're bonded together. So when an atom only has 2 electrons, the level 1 is full. This makes the atom very stable. For example, helium has 2 electrons in level 1 and that's it. Helium is a noble gas. Noble gases are very, very stable and happy elements. When an atom has level 2 full with 8 electrons, this also makes an atom stable as well. Neon, the next noble gas, has 8 electrons in its level 2, makes it very happy and stable. So there are certain atoms that are very stable, and that's when they have a certain number of valence electrons. And it makes them happy and very stable. And they happen to be the noble gases, which are all in the last column of the periodic table. So those are our most stable atoms. Basically, all the other atoms can make bonds and form molecules and compounds. Except for hydrogen and helium, which just want to have 2 valence electrons, most of the rest of the atoms want to have 8 valence electrons. That makes them happy and stable. So the noble gases, again, from neon on down, that last column, 8A, all have 8 valence electrons, and they're very stable and don't make bonds. So really what you need to remember from this is that the noble gases are stable and that valence electrons are the important electrons. So valence electrons. To figure out how many valence electrons an atom has, you simply go to the top of that column and look at the Roman numeral for the A groups. So when we look at our periodic table, the A groups are the ones that reach up high. So up here, this section here is the B groups, and we're not going to talk about them much at all, the B group elements. So again, the A groups are the ones that are up here. Now column 1 has a 1 at the top because it has 1 valence electron. Column 2 has a 2 at the top because it has 2 valence electrons. Now, we're going to call boron column 3. I know it says 13 at the top, but it's the third tall column, so it has 3 valence electrons. In fact, you should probably write a number 3 above boron for the third column. The carbon column is the 4th column, 4 valence electrons. The nitrogen column is the 5th column, 5 valence electrons. Oxygen column is the 6th column, 6 valence electrons. Fluorine column is the 7th column, 7 valence electrons. And helium is the 8th column, 8 valence electrons. Again, I'm talking about the columns that reach up high. So you might want to get a piece of, get your periodic table, get a pen, and just number the tall columns. 1, 2, 3, 4, 5, 6, 7, 8, right across the top. And remember, these down here are what we call B elements, group B, and we don't worry about them. And so you just look at the top of your periodic table and figure out how many valence electrons something has. So that's pretty easy. So let's try a few examples. P has how many valence electrons? Well, go to the top of the column and you should have written a 5 up there. So 5 valence electrons. Calcium, Ca, how many valence electrons? Go to the top of the column. It's the second column, so 2 valence electrons. Kr, krypton. Krypton's the last column. Go to the top. You should have an 8 up there. 8 valence electrons. And so that's how you know how many valence electrons there are. And that's pretty much what we need to know from this slide. So Lewis dot structures for atoms. What you need to know is the valence electrons that we just went over, and you put them as dots around the symbol of the element. So these are called Lewis dot structures. They show the symbol of the element surrounded by its valence electrons written as little dots. Now pretend the element symbol is in a square, so it has 4 sides. You need to put 1 dot on each side, and then you can double up and go around. So watch me. So we're going to put our first dot here. So 1, 2, 3, 4, 5, 6, 7, 8. And you can have 8 valence electrons maximum. So let's look at our examples. K. K is here in the table. And you go up to the top, and it's the first column. So it only has 1 dot. You can write it on the top. I wrote it on the side in this picture. It's okay. 1 dot. O. O, go to the top. It's number 6. So we should have 6 dots. 1 on each side. Then you can double up. So in the picture here, I have 1, then 2, 1, then 2. That makes 6 total. You can't have 3 on one side, in other words. Silicon, Si, right under carbon. Go to the top. You should have written a 4 up there. 4 valence electrons, so it gets 4 dots, 1 on each side. Silicon has to look like this, 1 on each side. Magnesium. Magnesium is right here, second column. You go to the top, it's the second column, so 2 valence electrons, 2 dots. And then finally, I, it's way down here for iodine. Go to the top of that column. You should have written a 7 valence electrons. So 1, 2, 3, 4, 1 on each side, and then we can double up 5, 6, 7. And so we only have 1 dot on the bottom in that picture, and that's fine. So that's how you do Lewis dot structures for atoms. Yes, you need to be able to do Lewis dot structures for atoms. Okay, we'll have a file upload question where you draw some Lewis dot structures for atoms probably in this course. All right, Lewis dot structures of molecules. Now, this gets really complicated. I will give you the Lewis dot structure for a molecule, which means 2 or more atoms bonded together. But I'm going to ask you questions about it. So basically, we're putting the dots of the atoms together. The goal is always to have 8 electrons around each atom, except hydrogen, which is a little bitty atom and it only wants 2, like helium. So you'll never see dots on hydrogen. Okay, so again, the goal is to have 8 electrons around each atom, except for hydrogen, which only wants 2. Now, you see these Lewis dot structures over here have dots, but they also have lines. What does the line mean? Well, that's a bond. A line is just connecting 2 electrons together with a line. So it represents 2 electrons that have been connected with a line. A single line is a single bond, which means 2 electrons. A double line is a double bond, which means 4 electrons. A triple line is a triple bond, which means 6 electrons. And then we have dots, and they're always in pairs in molecules. So you'll always see 2 dots together. So if we look at water, HOH, which is H2O, which is water, what kind of bonds are in there? Single, double, or triple? Single, right? Single bonds, because it's single lines. And there's 2 of them. There's 2 single bonds. How many dots are there in that drawing? 4. Or we could say 2 pairs, 2 lone pairs. So water has 2 single bonds and 2 lone pairs. Those are the kinds of questions I'm going to ask you. Now let's look at nitrogen, N2. What kind of bond? Triple line is a triple bond. Triple bond in nitrogen, N2. How many lone pairs? 2, right? 1 on each end. So 2 lone pairs in a triple bond are in the Lewis dot structure for nitrogen. All right, good job. Here's another Lewis dot structure. What kind of bonds are in it? Oh, there's single and double bonds. How many of each? 2 single bonds and 1 double bond. Good job. How many lone pairs? 2 lone pairs. Good job. So that was the CH2O structure. 2 single bonds, 1 double bond, and 2 lone pairs are in that Lewis dot structure. So we only do Lewis dot structures for covalent molecules, by the way. So what does covalent mean? A covalent molecule is only made of non-metal atoms, which are on the right side of the periodic table. Let's look at our periodic table. The right side is this side over here. So boron, carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, selenium, bromine, iodine, and the noble gases are pretty much our non-metals. Okay, I'm going to look for a different periodic table that has a line. We need a stair-steppy line here. The stair-steppy line divides the metals from the non-metals. Hydrogen's also a non-metal, by the way. Even though it's on the metal side, it's a non-metal. So covalent means non-metals. They're on the right side of the stair-steppy line. So the stair-steppy line divides the metals from the non-metals. So covalent just means non-metals. So examples are CO2, C and O, non-metals, and H2O, H and O, non-metals. So covalent means non-metal compounds. All right, we need some more Lewis dot structures. I'm going to show you in a minute. I want to know what kind of bonds there are, how many lone pairs there are, and I want you to see which atoms have 8 electrons around them and which don't. Let's look at this one first. NH3. What kind of bonds? Single bonds. How many? 3 of them. Good job. How many lone pairs? 1 lone pair. Which atoms have 8 electrons around them? Well, just the nitrogen, because it has 3 bonds around it at 2 each. That makes 6 plus 2 dots makes 8. The hydrogens, however, are just connected with the 1 bond, which is 2. So they don't have 8 around them. So nitrogen has 8 electrons around it. Hydrogen does not. New structure, HCN. What type of bonds do we have? A single bond and a triple bond. How many lone pairs? 1 lone pair. Which atoms have 8 electrons around them? Well, the carbon has a triple bond, which is 6, and a single bond, which is 2, so 8 electrons. Nitrogen has a triple bond connecting it, so that's 6, and then 2 dots, which make 8. Hydrogen, however, just has 1 single bond, which is 2 electrons. It's not 8. Hydrogen's never 8. New structure, CF3H. What type of bonds are in that molecule? Yeah, single bonds. There's 4 of them, 4 single bonds. How many lone pairs are there? Ooh, there's a bunch. 9. 9 lone pairs around those F fluorine atoms. There's 9 lone pairs. Which atoms have 8 electrons around them? Well, the fluorine has 6 dots plus a single bond is 2 makes 8. Fluorines are the same. Carbon has 1, 2, 3, 4 bonds at 2 each makes 8. Hydrogen, again, only has a single bond connecting it, so 2. It's not 8. Last structure, CO2. What type of bonds are in CO2? Double bonds. 2 of them. 2 double bonds. How many lone pairs are in CO2? 4. 4 lone pairs. Which atoms have 8 electrons around them? No, all of them. Oxygen has 4 dots plus a double bond, which is 4. So 4 plus 4 is 8. Carbon in the middle has 2 double bonds. So that's 4 plus 4 is 8. So 8. Yeah, all the atoms have 8 in that structure. All right, so again, those are the kinds of questions I'm going to ask you about Lewis dot structures. Watch this slide again if you need to. And that's where we're going to end this video. So we've talked about Lewis dot structures. Good job. Check you later, GCC Chem 107 students. Bye-bye.